And it felt like somebody had taken some gravel out the bottom of the fish tank and sort of thrown it at you.
You're listening to The Cosmic Cast.
Hello, and welcome back to another episode of The Cosmic Cast. You're here with me, Ricky Behir. We're here with John Purdett-Fisher.
Hello.
Marissa Lowe.
Hello.
And Tom Harvey.
Hello.
And we also have a great guest for you all today. We have Dr. Matt Balme from the Open University.
Hello.
How are you doing, Matt?
I'm very well, thank you. I'm upstairs in my attic office, sweating in the heat a bit, but I'm okay.
Yeah, we were just discussing with Matt previous to this that the Open University still aren't open again. Even though they called it Open University, they're not open.
Well, we're open for some of our lab workers, but I'm just an office rat, so I'm not allowed in yet. So
yeah. So I primarily know you through your Martian work from the Open University. I've seen you quite a few times at different conferences, and I understand you work in other fields as well. But we'll get on to that. But I would just be really interested to know how you actually got into your position at the Open University.
Well, it's actually a really long and complicated story. So basically, I did physics as an undergrad, physics of space science at UCL. And I did that basically because I was good at physics and I like space. So I thought, well, there's only 3 places in the country that do this degree: Leicester, Kent, and UCL. And the fact that I could leave my lovely but somewhat boring New Forest village home and go to the big city, and that's why I went to UCL. In my 3rd year, I had a lecture on planetary geology as one of the options from it was a lecture series, and this was from Professor John Guest, who sadly isn't with us anymore. But basically, I discovered that this was a thing that I loved doing and that I was good at, and that changed my life. I mean, I literally went from thinking that I wanted to do something with aerospace and engineering and rockets to thinking, wow, planetary surfaces are amazing. I really want to be exploring the geology of other planets. So I applied to a PhD. There wasn't a huge amount of choice in those days. So I really wanted to do something about Mars and water. But in the end, I did tectonism on Venus. And that was really good because I probably wouldn't have got a PhD on Mars water because I didn't have any real qualifications that were relevant. But the Venus PhD was all about experimental work. It was rock fracture mechanics. So it had some tricky maths and it had some, proper working in the lab, hardcore stuff. And so I'd done all this sort of thing for my undergraduate. And so I could, I had good evidence to say that even though, I hadn't done a lot of planetary, maybe they would pick me, and they did. So I did that, got my PhD, and then things got complicated. So I moved to the States for a postdoc. That was with Ron Greeley, also sadly not here anymore, and that was to study Mars dust devils. So I had the choice. Ron said, I was about to try and do my American accent, but I don't think I'm mad. You can do Mars dust devils, or you can do mapping Europa. And I said, well, I don't know, that's a hard choice, So, but I did Mars dust devils, and I spent time in the field. I spent time building a piece of apparatus called a vortex generator to simulate Mars dust devils. I took the vortex generator to NASA Ames and put it inside this massive low pressure chamber where they used to test rockets so we could simulate Mars. And we did that, and it was great. And I have to say, then I sort of had the choice of coming back to the UK or staying in the US. And I think for sort of personal reasons, my long-term girlfriend and now wife, was back in the UK doing her PhD at Open University, actually. And so, I came back to the UK. I got a postdoc looking at Mars again, but working for Beagle 2. So if everyone remembers Beagle 2. And then, of course, that didn't work. It crashed, or it didn't crash. It failed to open. We think it probably got there, but didn't complete. And my postdoc came to an abrupt end. So I did a few bits here and there.
Sorry, is that how that works in that situation then? So for
no, well, this was the problem. I think, to be honest, this is nearly 16 years ago, so maybe my memory is not so great. But I think what happened was the rolling grant system that they had in those days. You renewed it every year. Every 3 years. And so what happened was the rolling grant wasn't renewed. And so I was employed, basically for a few months at the end of an old rolling grant, and then our bit wasn't renewed. So of course that was tough. I'd made some contacts in the US. So I went back to Arizona, this time to Tucson, not Phoenix, and did a bit of postdocing there for a few months a year for Mary Burke, who's now at Trinity College, Dublin. And she had a huge influence on my career, to be honest, because she encouraged me to do more Mars stuff. And she encouraged me to write proposals. So I wrote a NASA proposal. And in the meantime, I got a short-term postdoc in France. So I went to Paris and looked at Mars gullies. And then the NASA grant got funded. So I went back to the US, and then I also got a postdoc at OU, again, looking at Mars water. So essentially for the next probably 6 years, I was working for 3 or 4 months a year in the US on NASA grants, and then the rest of the time back in the UK. So I would frequently change continent over a weekend, having stopped work on a Friday and start again on the Monday.
Oh.
So it was really tough. And then when my first child, when my daughter Isabel came along 10 years ago, I thought enough's enough.
Mm-hmm.
By that time I had a fellowship in the UK, an Aurora fellowship. And then that in the end was turned into a permanent position at the OU. And so I said, look, I'm just going to commit to the OU. So that was about 10 years ago. And I've been at the OU for the last 10 years. So as first of a research fellow, then a senior research fellow, and then a senior lecturer. And that's what I am now. So I said it was a bit complicated. So I hope I haven't bored the life out of you.
No, that's a roller coaster.
I feel we should applaud at this point. What a journey.
Yeah.
Well, I think the key thing for me was that I always knew this is what I wanted to do.
Mm-hmm.
I think from the year 2000 onwards, I knew what I wanted to do. And I just, every knockback or unfortunate thing that happened, I just said, look, just got to keep going. Mm-hmm. And I say this to all the postdocs who've worked for me, which is, I think, 7 or 8 now. It's really tough being a postdoc. You have no job security, but stay in the game as long as you can. Even if you have to move field a bit, just stay in the game, because eventually, if you want it enough, you'll get there. And I think there have definitely been times where I've thought, gosh, I wish I'd been an accountant. But then there's other times where you think, it's Christmas morning and I'm waiting to see if a space mission is going to land on Mars. So, even though that was a terrible time for Beagle 2, it was a horrible feeling, but the excitement of being involved in it was amazing. Mm-hmm. And so I'm really looking forward to that happening again in a couple of years for ExoMars. So, but hopefully with better results.
So that's a brilliant segue there into.
I'll just tee it up and you can knock it off.
You do all the work for us, man, on this one. So I've known you for years, and I guess the most time I've really spent with you there was when I went to do the ExoFit work in Harwell. So for anyone listening who doesn't know, ExoFit was essentially a prototype of the ExoMars 2020 rover, so the Rosalind Franklin rover. And Matt, how did you get yourself involved in that? And would you mind letting the listeners know a bit about that project?
Oh, I think this goes back a little bit further. So this goes back to an ExoMars-like rover field trial called Murphy, the Mars-Utah Rover Field Investigation. Now, the UK Space Agency wanted to run this. They wanted to give UK folk some training in how to be rover science team members. We had a relatively limited number of people who had experience with that. So that probably be just John Bridges, Suzanne Schwenzer, Sanjeev Gupta. So there was a guy from UK Space Agency called Mike Curtis Rouse who organised the field part of that, and I was brought on board to organise the mission control room side of it. So Murphy went very well. It was a lot of fun, and lots of people from around the UK were involved. So then when ExoFit came along, and this was an actual ESA funded thing, but it wasn't actually funded by ExoMars. It was a sort of slightly separate pot of money. So even though it was ExoMars-like, it wasn't necessarily specifically aimed at being an ExoMars sort of training mission. But nevertheless, I was asked to do the same thing I'd done for Murphy. So put that team together, helped Airbus, who are running the rover, get all that stuff together. And it turned out, I thought it went really well. There was some ups and downs, as there always are. Like the fact that it absolutely hammered it down with rain in Spain. So we didn't know this back in the control room. They hid it from us really well. But turns out they had some horrific weather, and some people were like up to their knees in mud, and then trying to find ways so that the rover wouldn't be able to see the muddy footprints and things like this. So that's how I got involved with that, and that was really, really enjoyable. And I think it's put the UK team who worked on that into a really good position for ExoMars rover. I mean, ExoFit included people from different countries, different instrument teams, but we had to find people to staff the console, as they say, and that was mainly UK postdocs, some PhD students. So that was, as you say, Ricky, that's why you were involved in that. So
did you say it was a working model of ExoMars that was out there, or is it?
It was an ExoMars-like
Right.
rover. So it had the instruments and it had all the capabilities, but it was actually an Airbus-produced field rover. So it wasn't specifically built to be exactly the same, but it was actually very similar in many ways. The only thing that wasn't the same was the analytical instruments, which obviously on ExoMars are all crammed into its stomach, but there's no sense doing that in the field. They were in a tent hidden around the corner.
So have you got much involvement with ExoMars 2020?
I have. I am involved in the Rover Science Operations Working Groups. That's sort of a big team full of people who are basically trying to define how we do the science we're going to need to do with the rover. And I'm also Deputy Science Lead for PanCam, which is the eyes of the rover. And so I've been doing a lot of, so we've just finished a big team mapping exercise where lots of people would be looking at the remote sensing. So that's about 70 people from across the whole of the ExoMars sort of community. So I helped lead that exercise. Did some geological mapping training sort of lecture stuff on that, and
you did a beautiful job of it, by the way, Matt.
Oh,
beautiful job.
Very much. And Peter Forden, who's one of my postdocs, he's done a good job leading a lot of the mapping side of that and sort of helping people to learn how to do geological mapping. Because obviously some of the people on ExoMars are engineers who focus on spectral measurements of minerals. They don't spend a lot of time looking at remote sensing. So it was good. We had a huge variety of different types of people with a big range of skills. So yeah, that was good.
So obviously you worked in your ExoMars work, and looking at your page on the Open University, I think you as you've already mentioned, the amount of pies you have your fingers in is more than I've ever seen before. You've got skill sets in so many areas. So I just want to take a step back to when you first got involved in looking at water on Mars as a subject area. So I know you've done subglacial work. You've also looked at gullies, as you mentioned. Where have you been taken recently? What's the most recent work you've had involved in that?
Well, I think the thing that I wish I'd done as an undergraduate was sedimentology. I think the thing that we are finding more and more is that Noachian Mars, so the oldest time in Mars, 3.7 billion years ago, it's just, the geology is stuffed full of fluvial sediments.
Mm-hmm.
So there were rivers on Mars then. And I think it's impossible to come to any other conclusion than that. And they weren't just rivers that sort of cut down through the highlands. These were things that were carrying sediment. They were depositing sediment. They were building up their own banks, making floodplains. They were meandering in places. They were avulsing to form new channels in places. The geology of Mars and the rivers of Mars going back all those years, that is a fascinating subject. Mm-hmm. So when we were trying to find a place to land ExoMars, which was a really tricky thing to do because it had a really big landing uncertainty ellipse, about 100 kilometers long. So you've got to find a big area that it can land. Quite severe constraints on the elevation that you can land in and the latitudes. So there weren't a lot of places to go. We found a really interesting area, which in the end became called Aram Dorsum. And if you look at a picture of Aram Dorsum, it's a long, wiggly, flat-topped ridge. Turns out that that's an inverted channel belt or an inverted channel. What that is it used to be a river, but for some reason, the material that makes up the bottom of the river has become erosion resistant. So as the river stops being active and everything's buried and then erosion happens later, that is left as a ridge, and all the stuff around it, the floodplains, that has been eroded more. And so now this is what you're left with. It's called inversion of relief. So we got into looking at that, and it's a really interesting story. It's a really amazing place. I wish we had gone there. We made it to the semi-finals in the bake-off contest for which rover landing site to go to. So we were third ranked.
Can I just ask what is the process then for that? So obviously you all go into the tent together and you present your landing areas, and Mary Berry comes around and looks at all of them. But what was the formal process that took place?
Basically, every year there was a landing site selection workshop, and every year one site was knocked out. Mm-hmm. So there was the landing site selection working group, who were a team of about 15 or 20 people from the planetary science community. They had to make the tough choice once a year, essentially. And so it was pretty stressful and pretty hard work. So, we got a grant from the UK Space Agency to look for landing sites. So this was all very last minute. The call came out from ESA. So, I went through probably about 30 different landing sites, and we found 2 or 3 that in our UK consortium. So one of the things I love about the UK is we have all these different groups working on Mars stuff, but we all work together. We're really good friends. We don't really compete so much as collaborate, and that's great. So that team came up with 3 or 4 good sites, and in the end we proposed 2, Hippanis Delta and Aram Dorsum. The 2 other sites that made it to the last 4 were Oxyapnum, which is the one that it's going to, and Mort Vallis, which has been proposed for pretty much every mission for the last 20 years. So you stand up and you do this sort of big 90-minute sort of keynote style presentation, and then you get grilled by the other people in the room, and then this sort of this group of people goes off into the dark room, and then you have to wait for the smokes to come up, black or white, and see which one gets chosen. So yes, it was there are times when I thought, why am I doing this? Because we have to give these massive sort of presentations, and I think we did a really good job. I mean, the people on our team put a lot of effort in, but I can remember being there at Lunar and Planetary Science Conference and knowing the workshop was the week after, and barely going to a single talk because I was just sat in my hotel room trying to get this massive 90-minute sort of presentation done, and just thinking, what are we doing? But in the end, it turned into a really, it was a really good turning point, because I was working on lots of recent Mars stuff, but by looking at the Aram Dorsum area, I started to look at old Mars, started to look at fluvial processes from the Noachian, so really fundamental to the search for life on Mars stuff. And so And then eventually, about 4 years later, I finished writing a paper about it. So yes, that was another long-winded thing, but
So
that's good.
are there still areas then in Oxyapnum that you're excited that Rosalind Franklin will be visiting from a sedimentological point of view? Or?
Yeah, I mean, the interesting thing about Oxyapnum is the geology is so subtle. It's really tough. It's a tough place to do mapping on. It's a tough place to try to interpret surfaces that you're seeing and the landforms that you're seeing. But we do know that if you go into the eastern side, there is definitely a down-cut fluvial channel, like a valley. There's inverted channels, which is the same sort of thing I mentioned before. So that means the whole place has been buried and then re-exposed. And it also means that sediment was deposited. So these inverted channels, they don't look like they were just filled in with lava. They look like they are the sort of things you find on Earth, where you have multiple little branches, you have slight modifications of the place that the channel was located. So there's a history of fluvial sedimentology there, and that's probably been wiped out by erosion. But it probably hasn't been completely wiped out by erosion. So we need to find those little bits of outcrop that we can go to and, and explore. The other thing, of course, is the landing site's a big site. So we could land, if we go right to one end of the uncertainty ellipse, we could land slap bang in the middle of what could be a delta or an inverted channel. If we go down the other end, we could land in the middle of just sort of endless plains of, well, clay-bearing minerals, which are interesting from a different point of view, but from a fluvial sedimentology point of view, perhaps not quite so exciting. But who knows? We don't know what we're going to find.
Yeah.
So what is it across all of these different projects that has captivated you about Mars in particular, as opposed to researching, other bodies in the solar system?
That's a really good question. I mean, I started my life on Venus. And Venus is exciting, but I think I started working on Venus towards the end of the Magellan era, where an awful lot of the big breakthroughs had been made. Now, I started working on Mars, towards the middle of the Mars Global Survey. And then within a few years, we had HiRISE, which has 0.25 meters per pixel. And that is astonishing. And when the more we see, the more we realize that Mars isn't simple. I would say that Mars has virtually the exact same range of, or variety of processes that happened on Mars that have happened on the Earth, with the exception of anything to do with life, probably. So we've got it's an immensely satisfying place to look at, because there's huge amounts of unknown stuff. It's a bit like being a terrestrial geologist in the 17th or 18th century, where everyone have suddenly realized that there's this amazing new science to look at, and there's new tools, there's new ways to get there. You can get on a train and go and look at an outcrop that's just a few hours away from where you live. And this is the same that we have on Mars. It's a hugely interesting place with a huge depth of interest. So yes, I think Mars is brilliant, and I keep getting tempted away to different places. I've done some stuff on Mercury, mainly through supervision of students. I've got a grant to look at the moon now, using machine learning to identify impact melts. So that's good fun. But there is something about getting a new high-rise image. It's one of these 25 centimeter per pixel images. And if you've got stereo coverage, so you can get 3D, and you put on the red-green glasses and look at the anaglyph, and you just go, oh wow, that's astonishing. There's amazing things you can see in high-rise that are, I think that is what has captured me and captured my interest. I think 20 years ago, I loved the concept of being able to simulate things in the lab, but I think in the last 10 years, I love the fact that you can see more and more stuff when you look in remote sensing. And then the last few years, I've been getting into rover level, interesting things. So I can't wait for ExoMars to start. I just want to go and start solving all those problems that it's like a detective story. We have all these ideas, we think we know who done it, but we want to actually go and start interviewing the suspects. So.
Matt, can I ask you? I guess this is going to be it's going to be quite an emotive question about Mars. There's a lot of debate in the community between whether Mars was once warm and wet, or whether it had what we called an icy highland climatic model. So for the audience, there's theories behind that Mars once, during the Noachian period, about 3.8 billion years ago, had a warm and wet climate that allowed rainfall to come down and form these valleys and river channels that we've been discussing. Or there was a load of ice, and the ice moved up into the highlands and melted and formed the valleys. Now, Matt, can I ask you, where do you sit on that topic?
Well, I think you have a lot of time available in the Noachian. So both could have been true at some point. What I will say is that in the mid-Noachian, we are finding more and more evidence of rivers that look like terrestrial rivers. They don't look like sort of mega rivers coming out of the front of a giant ice cap. They have small tributaries coming towards a main trunk. They're spread across a large area. They have the starts. These tributaries are at different elevations. They've clearly deposited sediment, and so they've aggraded. They've built up their own banks. They've spilled over. They're not single floods. They have a distributed source of water, so not a point source of water from one place. All of that to me says precipitation. So I understand that the Icy Highlands model is appealing because it's hard to model the atmosphere, going back into the Noachian, and it's difficult to make it work. The physics is hard. It doesn't agree with the observations from the geology, but I just see no other way other than precipitation to explain a lot of the things we're finding now. This is stuff that people have found in the last 4 or 5 years. So, you could argue that, going back all the way to the Mars Global Surveyor era, hints of this. A few people have been publishing, mainly from the US, about Mars was probably had precipitation. There were probably long-lived rivers. So, but again, maybe this was a 10 or 100 million year period, which actually is a huge amount of time. So maybe it's a bit of both. But we don't know the answer, and we will have to go to more than one place on Mars with a really good rover or people if we want to solve this. That's my feeling anyway.
I was wondering, Ricky, where you were going with this is a very emotive question now.
In our community, that's a very emotive question.
Okay.
Yeah, it is. I thought you were going to ask, is there life on Mars? Which is another have to beat around the bush there and sort of give some non-committal standard.
Yeah.
I'll get in trouble whichever way I go if you answer that one. So.
I've got a question just going back from what you said, you're doing your PhD research and earlier research on. Good, we glazed over this. Dust devils. This sounds very, very cool. Would you mind explaining what they are? I mean, both on Earth and then on Mars.
Okay. Well, dust devils, I spent several years working on dust devils. It was my working on aeolian processes, so things to do with the wind and how it interacts with the sand or dust. Been a huge part of my early research career. So a dust devil is a vortex, like a little whirlwind. They are driven by the sun's heat. So the sun heats the ground heats the air. They form sort of convection at different scales. And essentially, dust devils are convective vortices. Now, these happen all the time. You can't normally see them because they don't pick up dust. When they do pick up dust, you can see them, and they can be really spectacular. They can be a few tens of centimeters across, or they can be hundreds of meters across.
Oh, wow.
some of the ones that I've seen and sampled in Arizona and Nevada and Utah, the southwest of the US, you'd be forgiven for thinking it was a tornado. They are really, really impressive. They whiz around at a huge rate, and they can be incredibly dust loaded. You know, you can't even see out of them if they come over you.
So sorry,
Now,
we just seem to glaze there over you sampled dust devils.
Well, what we did is, so this was work I did with Ron Greeley and his team. So as a postdoc, you know, we had this opportunity to go into the field and sample them. So we built ourselves a very entertaining little sampling system. It was the acronym was COTSBOT, which stands for chuck out the back of the truck. I think I got that right. So basically, we're on the back of a pickup truck, two people on the bed of the truck with this plywood contraption covered in instruments. And the guy we were working with was a guy called Steve Metzger, who had done a lot of work on dust devils. And he would drive along across the desert at a scary rate. And he would skid to a halt in front of the dust devil. And we would leap out the back of the truck, and we would take COTSBOT and put it down in the path of the dust devil. The dust devil would then hopefully go right over COTSBOT, and we would collect the data on the data loggers. So that was great. A few years later, we had a better idea, and we actually instrumented the truck itself. So we've done several things like that. So yeah, so driving across the desert at 100 miles an hour is on the back of a pickup truck, holding on to some expensive hardware. It's quite entertaining.
So before you'd actually ever seen one in person, I assume you'd seen videos of them, but what did it feel like to actually be face to face with one for the first time?
Well, yeah, it's most of the ones we sampled that year were pretty small. Then a few years later, I was doing more field work. This time we had spotters who were basically taking pictures of the dust devils from different angles to measure, use stereo imaging to measure their diameter and stuff. And I was a spotter, and I was on top of my pickup truck. I lived in the US, and in the Southwest, I had to own a pickup truck. And this thing came over me, this huge dust devil. So, I was sitting there thinking, it's just a dust devil. And then it got closer and closer. And as it hit me, I was like, oh no. And I put my hands over my eyes, like cowered down in my truck. And then after it had come over, I was a bit embarrassed, because basically it was nothing worse than a lot of wind. And it felt like somebody had taken some gravel out the bottom of the fish tank and sort of thrown it at you. It was nothing worse than that. But I remember very clearly sort of looking at the corner of my eye, trying not to get dust in my eye, and seeing like the inner wall. So it has a clear core. The wall whizzing around. It was very Wizard of Oz. So, but yes, and then people love running into dust devils. If you ever heard of the festival Burning Man, always have dust devils at Burning Man. There's loads of videos of people under the influence of various things running naked into dust devils and things like woohoo.
And you were never tempted to do that yourself, Matt, when you're out doing your sampling?
What happens on field work stays on field work. Fortunately, when I was doing field work, it was a little bit before the everyone's got a smartphone generation. So I've never ran naked through a dust devil.
Are they quite long-lived features, or is it really a case that you've really got to sprint there as fast as you can once you spot one?
Well, some of them can last a long time, an hour, 2 hours. So
oh, really? Wow.
They can travel very long distances.
Wow.
Of the order of, a few kilometers to 10 kilometers. Most of them will only last a minute or two, maybe 5 minutes. So when we're doing this surveying approach, we sort of designated a sort of a kilometer area. We had meteorology towers to measure the ambient winds, and we would basically wait for these dust devils to come across our study area, and then we'd photograph them at different times to record how fast they came through, where they went, how they responded to the wind. And whilst we were doing that, Steve was in his truck lancing them with the instruments. So it was,
That's really interesting.
Having done all this stuff on dust devils, I've sort of been trying to move on from dust devils for years, but I keep getting dragged back into doing more dust devil work because it is good fun. And you see them on Mars. They're even bigger on Mars.
Mm-hmm.
You can see them, a kilometer across,
Wow.
many kilometers high. So yeah, it's going to be interesting because ExoMars definitely, ExoMars rover and Oxyapnum, that site definitely has some dust devil activity.
Mhm.
So we should be able to see some if we're still working in the middle
So
of the summer.
What's the end goal behind understanding dust devils then? Like, what does that tell us then about the sort of the bigger picture on Mars?
Well, I think one of the things that has been a perennial problem in Mars aeolian research is how winds on Mars pick up dust.
Am I
The
right in
atmosphere is
thinking
really
that?
thin,
Yeah.
so theoretically you shouldn't be able to.
Mm-hmm.
So one of the things that people have been thinking about is whether dust devils can provide a sort of a missing link. Mars's atmosphere is really dusty all the time, but if the winds aren't strong enough to just pick up dust, because very fine dust actually sticks to itself. It's harder to pick up very fine dust than it is, say, 100 micron sand. So you have these theoretical ideas, and so that's one of the main reasons people study dust devils. Dust devils are also important because they can clean your solar panels. So if you're a solar powered rover and you are running out of lifetime and the dust devil comes along and it scours your solar panels clear of dust, then it gives you a new lease of life. So, and we think they can also form discharges, so there might be possibility of interesting chemistry triggered by electrical behavior. And maybe, we know that dust devils on Earth can get highly charged because they separate large and small grains that are bouncing around and hitting each other. You can get a big potential difference across a dust devil. Now, obviously, we don't want to kill off our Mars rover by shorting it out because of lightning induced by local lightning induced by a dust devil. So that's there's pretty good reasons to study dust devils, and they look really cool.
Yeah.
So how do you go about studying the dust devils on Mars if they can be quite short-lived features and if they're on the move?
Well, amazingly, we have lots of pictures of active dust devils on Mars. So not only can you see the tracks that they leave, because on Mars we don't have any vegetation or whatever, you actually see that where they've moved across the surface because it's altered the sort of the reflective properties of the surface. So you can see these amazing tangled wiggly tracks going across parts of Mars, and those are dust devil tracks. So you can look at those, but you can also just see them actually active on the surface. You can see sort of columns of dust with a big shadow cast on one end. And some instruments that we have, so for example, the high resolution stereo camera on Mars Express and the Cassis instrument on Trace Gas Orbiter, ExoMars Trace Gas Orbiter, they have instruments that take images of the same part of the surface, but a few tens of seconds apart or a minute or two apart. So we actually have plenty of data of actual dust devils. Here's a dust devil in one place, and then in the next image, it's moved a few hundred meters in the next place. So there's absolutely convincing proof that those are dust devils. And yes, and then you can do things, one of the things I've been doing is trying to measure their forward velocity using these multi-imaging techniques. So that's something I had started with this dust devil work on Earth. So I said we had this survey idea. We're using the stereo cameras to plot how fast the dust devils move. So we've just tried to do the same thing on Mars using Cassis and HRSC data.
So I don't know if you knew this, Matt, but at the moment I'm actually working for Rolls-Royce as a postdoc.
Oh, right. Congratulations.
Thank you. Don't worry, I'm going back to Mars in February.
Well, I hear that Rolls-Royce is the Rolls-Royce of companies. So.
Yes. Very good. Leave the jokes to me, Matt. It's my only job on this podcast.
Oh, you can edit that bit out.
So as part of what I'm doing is I'm trying to understand on terrestrially the composition and grain size of dust in the atmosphere, because obviously as planes fly through it, it can damage the inside of the engine. So on Earth, do these dust devils have the potential to actually lift up quite coarse material into the atmosphere?
Well, yes, but only for a short distance.
Right.
If you lift something that's more than about 60 microns in diameter, then it just falls back down again. If you lift something that's under 10 microns, it can stay in the atmosphere for a long time. Now, people have been studying these things on Earth since the 60s. There was a guy called Peter Sinclair, and he did the most amazing PhD study of dust devils. He was like the father of dust devil research. He had this Jeep with essentially massive scaffolding poles on top of it. And it was insane. It looked so Heath Robinson, but he sampled dust devils. He drove across the desert in a Jeep with like a 30-foot tower on top. I'm not joking. It was huge. And he did the same thing we did, but far more dangerously. We got some really good data. He also was what they call us in the US a sailplane pilot, which I think is a glider pilot. So he had an instrumented glider, and he would glide over the dust devils, because that's where you get the thermals. They indicate. In the States, people look out for dust devils to put their gliders over, and say that he was finding differences in the vertical wind speed kilometers up. And so, I don't think dust devils on Earth really affect the air quality significantly, because we have winds that can themselves, just regular winds, can pick up loads of dust. We have dust producing processes on the ground, especially agriculture, highways. So dust devils, they might affect air quality in local places where there's loads of dust devils, but I don't think they're going to be something you need to worry about for Rolls-Royce engines, so in planes.
So I guess my final question on the dust devils activity work is, do you still feel the same rush sat behind a computer looking at images as you did when you used to drive through dust devils to sample them?
I think the answer is probably not. I mean, it was exciting, don't get me wrong. There's also times where you've driven over a 1.5 meter wide, meter deep gully in your boss's 4-wheel drive vehicle at 100 miles an hour, and you think you've just lost the rear suspension. So that doesn't happen anymore. So having said that, we still do loads of field work in different places. I'm heading off to Iceland, I hope, next year, COVID permitting. So I still do some field work, so I still enjoy that stuff.
And is Iceland, are you doing debris avalanche work? Or?
No, we're actually going to test the PanCam emulator, and the way we use PanCam, again, to look at aeolian deposits. So we're going to find wind abraded rocks, and we're going to find mega ripples, and we want to use it in natural environment and work out essentially things like what angles we need to be looking at, how far we need to be away. You never know what the best way to use an instrument is until you've tried to use it. So it's easy enough to say, well, look, theoretically, you should be able to see X grain size, or use it in the lab. But for the sake of a few £1,000 to take it out into the field, it's really worth doing.
May I ask why Iceland?
Because we couldn't afford to go to Argentina, I think, is the quick answer. No, I mean, it's a place that we know these landforms exist. My postdoc, Eleanor, she did a bit of work in southern Argentina, but obviously it's a lot more, logistically, it's harder. Iceland is nearby. We've been there many times before. So even without COVID, I think it would have been at least double the price and probably double the length of time to you've got to allow yourself enough, what's the word? Spare time in case things go wrong. Things always go wrong with field work. So contingency, that's the word I was.
Well, I'm afraid, I think, although we've only scratched the surface with you today, Matt, it's coming to the end of the episode, and we always have a certain question we ask the guests at the end of the episode. So if Marissa would like to ask the question.
Yes. So, Matt, if you could be doing anything else, either in academia or outside of it, what would you want to do?
What would I want to do? Well, I have two answers to this. The first one, because this is a question I've been asked before. The first one would be to be a professional racer of classic minis. So I like a classic mini. I currently don't own one because my wife tells me that 4 cars are too many. I have a very ancient MX-5 track car, so that's my. I haven't used it all summer. It's been really sad. And the other one is the classic answer of all planetary scientists, which is I'd like to be an astronaut. I would. When I was younger, I really, that's the thing that drove me. And then I discovered planetary geology, and I thought, well, actually, maybe this would be really good. So mainly I'd like to be an astronaut so I can go to all the places that I've written papers about and be like, oh, you idiot, you were wrong there. Oh, no, you were wrong there. And then maybe eventually I'll be like, there you go. I told you that's what that was. And I'm right. So it would be nice to have that.
Amazing. Have you ever considered applying to be an astronaut?
I haven't actually, no. I think having known some people who got very close when I worked in the States, who got very close to being astronauts, and I think I realized that maybe when I was younger, I might have had what it takes. I think by the time I got into my mid-20s and 30s, I probably am, better off not being the sort of person that risks it all, essentially. I think having I think I have too good an imagination for things that could go wrong. So,
but you could be the first person to race a mini round Mars. Imagine that.
That'd be great. It'd have to be an electric one, but I think that'd be pretty cool. So,
It'll be more interesting than Tesla anyway.
Well, yeah, maybe.
Well, I think we should just say thank you very much, Matt. It's been an absolute pleasure. Absolute pleasure. We'll have to have you on again for sure.
Okay. Well, I really enjoyed it. It was really good. And it's certainly nice to talk to some different people over the internet rather than maybe next time we can do it in person. I hope so.
I hope so. Yeah. Brilliant. Well, Matt, thanks very much. And to all our listeners in the audience, of course, thanks for watching and listening as well. We're on social media everywhere, from Twitter to Facebook to Instagram. You can find us at Earth and Solar System. Links will be in the episode description. But until then, Matt, thanks once again, and we'll see you all next week.
Bye.
Bye.
Bye-bye.